right, let's get this started. Hello, everybody. Thank you for joining us today. I would like to welcome everybody to our first webinar of this new year. We are very excited to kick off 2024 with our wireless webinar on Wi-Fi design. This is actually our very first Wi-Fi webinar that covers the design aspect. For those of you that tuned in with us last year, you may remember we have had covered several other topics in the wireless webinar series. Here's a list of our past videos and YouTube links for those who may have missed it. But yes, we have done one on Wi-Fi fails, one on the overview of Wi-Fi 6, 6E, 7 the 7 technology, one for troubleshooting tips and tricks, and one for Wi-Fi security. So yes, if you have missed us and have some interest, please check out our link in our YouTube channel. But yes, this is the first time we're going to talk about what goes into designing a wireless deployment and all the fun stuff that goes with it. I think it's a great way to start off this year's Wi-Fi webinar series. So yeah, let's get rolling. Some housekeeping items. This webinar will be recorded and will be available for replay after today's session on our YouTube channel. Audio will be muted for our audiences, but there is a Q&A box at the bottom right corner. For any questions that may come up, please enter them into this box. We will try to address them as they come in. We will also have a Q&A session at the end of the webinar if time permits. Okay, so let's move on to some introductions. Hello again, everybody. My name is Jackie Fukushima. I am part of the LA Networks team of engineers. I have been with the company for about 4.5 years. I've had the opportunity to really focus on the wireless technology these past couple of years, and I've taken part in various new Wi-Fi deployments, refreshes and upgrades, and it's really thrilling to see that more and more companies and various industries are transitioning into the more wireless centric type of environment. So I'm really excited to learn and talk about this topic today. Just a quick intro on who we are. LA Networks is a leading IT service and solutions provider. We have been servicing the Los Angeles area for over 20 years. We also work on a global and national scale. We are an engineer-driven company with over 70% of our team members comprising of engineers. We do specialize in multiple different verticals. Today we are talking about wireless, but we have technical presence and expertise in enterprise networking, data center networking, security, collaboration, and cloud networking, to name a few. And most of our engagements do come from repeats and referrals. So we do highly value the relationships that we build with our customers, and we commit to providing the best services possible. So without further ado, I think we are ready to kick off this webinar.
Thank you, Jackie. Good morning, everyone. My name is Jan Greben. I'm a systems engineer here at LA Networks. I work with Jackie quite a bit. And as she said, today I have the ultimate pleasure to talk with you all about one of my favorite subjects in the world, and that's wireless design. So as Jackie mentioned, if you do have any questions or comments, for sure, please don't hesitate to ask them. Sometimes, as my friends say, I have a tendency to get really into the discussion at hand, and I don't pause enough for questions. But please don't let that prevent you from asking questions. Jackie can stop me at any time. If you have a good question, just submit it in the Q&A, and we can for sure address them. So today we have wireless design, and we've kind of broken it up into 5 primary steps or stages. We start with the gather requirement stage, and this is where we ask the questions of what are the business requirements, or maybe what about the network requirements. Then we move to the consider the details stage, and here we start planning the design out, and we start looking at what kind of Wi-Fi and equipment we need. Maybe is this Brownfield, Greenfield, or is it indoor or outdoor? And we'll dive into each of these sections into more detail as we go along, so don't fret like if you don't know what Brownfield or Greenfield is. We'll be diving into each one of these stages. But then stage 3, we get to the creation of the design. And this is we actually put pen to paper and we start creating our design on a floor plan or a drawing or whatever it may be. And then stage 4 is we're taking that design and we're converting it, or we're creating a bill of materials to make it actionable, right? We can actually get it priced out and budgeted and procured. And then stage 5, we have our validation, our changes, right? Wi-Fi is iterative, so we want to make sure we validate our designs and adapt to any changes that come up. Now, the astute of you might notice that there's only really one step that's dedicated to the actual creation of the design itself, and that's step 3, and that's entirely intentional, right? The reality is when we're working on a wireless design, we actually spend more time on pre-design and post-design steps than we do on actually creating the design itself. I'd guess it's probably something like 80% of the time we're doing, gathering requirements, researching, validating, and then only about 15 or 20% of our time is spent on creating the design itself. And I don't think that's unique to wireless. I think the same can be true for networking designs or collaboration designs, but it's especially true for wireless. So we start off with our business requirements. Right, let's start gathering requirements for our Wi-Fi design, figure out what we need. Because if we don't have a good grasp of the business requirements, then we can't really create a good design that meets the requirements of our organization. Right, so we start with, why do we need a Wi-Fi design? Why are we even doing this? What's the business need driving this request? Is maybe our organization considering going to our wireless first approach, where most users are connecting over Wi-Fi rather than being hardwired in? Or maybe this Wi-Fi is going to a location or an area mostly for our customers to use while they're in our facilities. But how do we expect the Wi-Fi to be used will have a significant impact on how we choose to design that Wi-Fi. Right, another question is applications. What applications do we expect to be used over Wi-Fi? Do we think it's going to be mostly maybe email and browser traffic? Or do we expect some real-time collaboration applications, right, like a Zoom or a WebEx is going across our Wi-Fi? And then what user density do we expect? Do we think this is going to be mostly, typical office or cubicle space? Or do we expect some meeting or conference rooms? Or maybe it's a high density space where we have a lot of customers and they're going to this area and we need to service all of them in a very tight space. And then client devices. What client devices do we expect to use our Wi-Fi? Are we thinking maybe this is going to be mostly company issued devices? Maybe devices we have some control over. We have a certain standard of what devices will be connected to the Wi-Fi. Or is it going to be a hodgepodge of different devices with wildly different ages of the devices, and we can't really control that? Our design will depend on that as well. And then also things like what kind of guest access are we going to want to offer? That'll affect our design. How much roaming do we expect the users to have? Right? Are they going to be mostly using the Wi-Fi while they're stationary, maybe at their cubicles? Or do we expect the users to be using Wi-Fi on their phones as they're walking from one end of the building to the other end of the building? And then other things like location tracking. Do we want to provide any kind of location tracking? Because if we do, right, whether it's tracking of devices or tracking of customers, that significantly impacts our design because it has to be a lot more dense to support the triangulation of different devices. So all these questions are things we have to consider before we even get to, hey, I want to create my design. Let's figure out the requirements. Let's gather requirements, especially the business requirements. And then building from that, we also have our network requirements, right? So we need to vet how does our Wi-Fi need to fit into the whole overall scheme of the network itself, right? Is there an overall network architecture we need to fit into? Is this going to be, Wi-Fi going to be independent, or are we expecting maybe this Wi-Fi design will span multiple locations and it needs to speak back to a central location or controller? Are there going to be maybe any layer 2 or layer 3 requirements for our Wi-Fi that we need to consider just from a design perspective or an architecture perspective? And then from a security perspective, right, what security requirements do we have for our Wi-Fi? Because that can have a significant impact on our design as well, and especially the planning of it, right? Maybe we as an organization use a NAC solution, something like Cisco ICE, and we need to integrate our Wi-Fi into that. So for sure, we need to be able to figure those questions out before we really dive in to our design itself. So as we've gathered requirements, we kind of start moving into okay, we have started to get an idea of what we might be doing, and we start to, ask us questions, the big picture questions first. So like, what kind of Wi-Fi do we think we need, right? Are we looking at maybe 2.4 gigahertz or 5, maybe the 6 gigahertz space? And then from a standardization perspective, right, do we think this is going to be mostly a Wi-Fi 6 or 6E if we're using 6 gigahertz? Or are we in the cutting edge and we're looking at a new, Wi-Fi 7 network when Wi-Fi 7 is ratified later this year? That will have an effect, and it'll have a significant effect on our planning of the design phase itself. I do see a question being asked of if there is content being displayed. Yes, the slides are shown right now. If you do not see the slides for some reason, please let us know. But yes, we have been going through slides one by one. If you don't see them, please put in the Q&A or let us know if you can't see any of the content. Okay, so we've kind of gone through. We have an idea of we think this might be the kind of Wi-Fi we want, and we start to dive deeper, more granular, right? We start to figure out, okay, what kind of APs do we need? And we don't have to make any hard decisions at this point, right? We're not saying, oh yeah, I specifically need this AP and I know that for a fact, and I'm not going to waver or change my mind. We just want to have an idea of what kind of equipment might we need, right? For example, based on the requirements we gathered from the business or our network or security requirements, do we think we need a controller-based Wi-Fi architecture, right? Or maybe controllerless, or rather, controlled in a cloud, something like a Cisco Meraki. And then for APs, do we think this will be mostly omnidirectional? Or is this going to be, are we going to need some specialized access points that are directional or maybe have external antennas? And then closely related to that, it's important not to forget the technologies that our Wi-Fi relies on, right? So for example, are we going to need new network switches for our Wi-Fi? And if this is a new deployment, then almost certainly the answer is yes. But if it's an existing deployment, then the answer is maybe, right? Maybe we'll need new switches, and we need to figure that out. Is that maybe leaning towards a yes, or is that maybe leaning towards a no? And the type of switch will depend heavily on the kind of APs we think we'll need, right? So in the previous slide, we looked at what kind of APs we think we need. Based on what direction we start going there, we can start going, with our switches. So for example, if we expect a dense environment and we need very beefy access points, then we'll need beefier switches to support those access points. And when I say beefy, we're talking about, bandwidth requirements and power requirements. So from a bandwidth perspective, it's possible maybe we need switches that can support more than 1 gig, right? Maybe we need multi-gig switch ports that can support 2.5 or 5 gigabit, right? And the beefier the AP, the beefier the bandwidth we need. And then from a power's perspective, right, we need to make sure we are providing ample power that the APs need. The more capable your access point, the more power it needs. Now, luckily, most of the vendors have anticipated these needs, and a lot of them have switch models that can do both multi-gig and then also provide more power. So, 60 watts of power, or even 90 watts of power per switch port. So if you're going for the high-end AP that needs to support your, very dense environment, you have the bandwidth for it, and then you also have the power via that, UPOE port or something like that. And then don't forget about the structured cabling as well. So if we're moving APs around, then for sure we'll need new cable drops to those locations. But then even if you're not moving APs around, even if you're limited and the most part APs won't move too much, you might still have old Cat5 cabling and you need to upgrade to Cat6 or even Cat6A. So these are, auxiliary supporting technologies to Wi-Fi that can often be forgotten, but it's important not to. You can't just do, a Wi-Fi design with access points, install them and go, oh crap, I don't have the switch architecture to support it. I don't have the cabling to support it. So this is very much part of that same design. And then the next step from there, right? Okay, so we've kind of figured out the equipment we might need, maybe the switches we'll need. And we mentioned it before, right? If there's an existing environment, we might need new switches. So this is where we jump into Brownfield versus Greenfield. And so one of the most important questions you can ask is this going to be a new deployment or is this going to be an existing deployment, right? So Brownfield is our existing deployments. And then Greenfield, it's a brand new Wi-Fi deployment. There's nothing currently there. And we can do, kind of what we want. So with Brownfield, we have limitations. We're going to have limitations. We mentioned it earlier, right? The cabling, that might be the wiring. Maybe there's physical limitations of where we can and can't install. Or maybe there's an access issue, right? Maybe we can't access certain parts of the facilities. I've seen that be happening with Brownfield quite a bit, right? Where you have this design, you're working on a design, and then you realize, boy, the way the building was built, it's really difficult to run a cable to that location, or it's just we can't access it because there's a piece of art underneath it and it's just too dangerous to get to that location. So those are some limitations we have with Brownfield. Now, one of the things I always recommend if you are working on a design for a Brownfield deployment, I recommend assessing the existing Wi-Fi, right? Is the current Wi-Fi that's there, is it working well? Or there may be some issues, or maybe there's some coverage gaps. If you're able to perform, right, if you have the time or the means to perform a wireless site survey of that existing Wi-Fi, you're going to be positioned a lot better for success with your new Wi-Fi design, right? You're going to have a lot of insight. So if you can get out there, site survey the current Wi-Fi and see, hey, do I have coverage gaps or is this working quite well? Are users complaining about the Wi-Fi? Or is it simply a time where I need to refresh it and don't fix what's not broken, maybe just upgrade it, move some APs around, maybe create a little bit more density for future-proofness, but we're not drastically moving APs around? Or is this a situation to where you have some coverage gaps, or people are complaining, or you just haven't upgraded the Wi-Fi in 12 years, and it's like, hey, I don't want to do what I had before. I want to change it around. So for Brownfield, that's why I recommend gathering as much information about as you can. That's about the facility. Get the most accurate floor plans. If you can't, maybe when you're doing a site survey or just otherwise, take measurements of the facility with like a laser device. Measure the ceiling heights, the room sizes, the lengths of the corridors, any additional information you can get on your existing location. It'll just make your design that much better. And then we have Greenfield. With Greenfield, it's a new design. These are honestly a Wi-Fi engineer's dream. We have a lot more flexibility and room to customize with Greenfield, but there's a caveat to that. The earlier we get involved in the process, the more flexibility we have. So especially if this is a renovation or new construction, I advise to get involved early in the process, right? See if you can sit in on some of the construction project meetings. And, if you see a decision being made that will make it more difficult for you to create a good wireless design, or maybe hamper your ability, to place AP somewhere you want it to, don't be afraid to speak up. In my experience, I've honestly found, architects or construction project managers, they're willing to work with you and will even meet some of your requirements as long as you communicate with them, well ahead of time. Communicate your needs clearly. In my experience, there's nothing more that a GC hates than somebody telling them well after the fact that they have some specific need or some niche need, and you're telling this to them at the blue tape walkthrough when everything's already completed. They probably won't acquiesce and help with your need then. So get involved early. Get some say. So if you have an idea of where you want access points to be, yeah, I would say get involved early. But otherwise, this is a dream because we have full customization. Right? We can customize our Wi-Fi almost exactly how we need in most, or in good situations. And then beyond just Greenfield and Brownfield, the location of our facility matters itself, right? And when we say location, we're talking about our neighbors, right? So people often miss considering our neighbors and what's around us. So what organizations are around you and what wireless technologies are they maybe using? That can have a drastic effect on what kind of Wi-Fi you're actually able to design, right? Because other people's Wi-Fi can eat up the channel space around you, and it'll limit how many channels we're able to use for our own Wi-Fi. So for example, right, if you maybe are designing a Wi-Fi for a small branch office, and it's packed into a large corporate space, right? And there's lots of other suites around you, then maybe we can't use 2.4 gigahertz as well, just because we only have the 3 channels in 2.4, and maybe it'll be eaten up by everybody else around you, and we can't really design a very good 2.4 gigahertz Wi-Fi, and that's just going to be a limitation based on our neighbors. Or, and this is something I've seen, is with 5 gigahertz, right? Maybe we have an airport in close proximity or a military base. We have a few customers that have military bases close by. And if so, airports and military, they get first dibs on a significant portion of the 5 gigahertz channel space. We call those the DFS channels. They're right there kind of in the middle, and they make up half or just over half of the 5 gigahertz space. And if you are one of those people that's close to an airport, you're going to be limited to just the 9 non-DFS channels, right? And that's important to know because as we're designing our Wi-Fi, sometimes our density is limited by how many channels we have. So in 2.4, we only have the 3 channels, so we can't make a very dense design with 3 channels. With 5, we have a lot more channels, but if we have an airport next to us, maybe we're limited to just those 9 channels, and all of a sudden it's maybe not as flexible as we want it to. And this is where we do see a lot of people moving or trying to start using 6 gigahertz, right? The Wi-Fi 6E that's just come out in the last couple of years, it's still pretty new, but most new devices support it. And with 6 gigahertz, we don't have the same limitations of 2.4 or even 5. We have so many channels that for the most part, we don't care that much about our neighbors. You won't run out of channels for the most part, even in a very, very dense design. So that's something to consider if you are one of those people that's limited by channel space. Look at maybe using 6 gigahertz instead of the traditional 2.4 or 5. And then kind of building on that is the indoor versus outdoor discussion, right? So is this Wi-Fi going to be indoor or is this Wi-Fi going to be outdoor? And if it's indoor, we need to consider the different types of indoor spaces, right? Is this maybe a typical office environment, with a dropped ceiling that's 9 or 10 feet? That's by far what we see the most common. Or is this maybe a warehouse, right, with 35-foot tall ceilings and tall racks that are, heavily packed with water-based products? That'll affect our design significantly. And then in indoor spaces, we do see aesthetics come into play quite a bit. Now, are we going to be able to place APs wherever we want, or are we going to have some limitations because our organization has a certain type of aesthetic that they want to meet? And so these details can have significant impacts on our design. So, for example, this kind of picture here on the left of the indoor space, I'll be honest with you, that looks like a pretty difficult space to design Wi-Fi for. It looks like aesthetics for them are very important, but everything looks very pretty. I don't see any access points anywhere, so it's possible they have to have them hidden, maybe masked somewhere, put them in far and away places, kind of hidden places. I do see different ceiling heights here as well. Kind of on the right there, we have a lower ceiling, and then in this common area, we have these very tall ceilings. And not just that, but we have a tall exposed ceiling with lots of metalwork and lights and everything exposed, which means we can't just put an access point above that because all that metalwork and ductwork will impact our signal. So we have to figure out, how do I put Wi-Fi into this space with the limitations of the aesthetics, considering the ceiling heights, and considering I can't really put APs where I want them because, let's say our organization doesn't allow us to put an AP on a pendant mount and have it hang down. All of a sudden, that affects how we're going to design it. It's not going to be the same as if this was just a drop ceiling space with 8-foot ceilings. You could just put APs wherever you wanted to, and you probably wouldn't have an issue. And then last but not least, within indoor, there is the important question of coverage versus capacity, right? And this, the answer to this kind of depends on our requirements. Like so many other things we're doing here are, requirements gathering and information gathering phase. What did we find out, right? Is this going to be a dense environment to where we need to do capacity, or are we just doing coverage, right? Are we just trying to make sure that we have, let's say, negative 67 dBm signal strength to all areas? That's just coverage based. Or it's like, oh no, actually this is a high dense area and we only want to have, so many clients per AP. All of a sudden we have to start making it more dense, and we're putting APs closer together, even though they already all have great signal strength. It's just because we're trying to limit the number of clients per AP. And then for outdoor, we have very similar considerations with a few differences, right? So for one, installing and mounting APs is just not as easy outdoors, right? Maybe do we have poles we can mount to, or sometimes you'll see people mount APs to the sides of a building. But either way, it's more difficult, right? You can't just put an AP in a ceiling and say, okay, it'll cover this little circle or space. Sometimes we have to shoot it at weird angles. We have to make APs directional just to be able to propagate the signal, to the specific area we want it outdoors, keeping in mind the limitations of where we can put it. Aesthetics come to play here as well, right? Sometimes you can't put APs where you want due to aesthetics outside, similar to indoor. And then outdoors is where we do run into some limitations of regulations, right? So in the US, we have the FCC that regulates radio frequency transmissions, and they have regulations on what kind of bandwidth you can use outside, what kind of strength it's set to, right? So when we're designing for outdoors, we have to be careful about maybe some of the transmit power settings, and we can't just put a directional IP and put it at a high power to get it to this one weird spot, because we can't shoot signal that strongly or that with that high of a transmit power setting outdoors. And so those are just challenges we have outdoors when designing Wi-Fi, and something we need to keep in mind. And then I forgot to mention one small thing that well, not small thing, but one thing that gets forgotten about quite often, that I see at least for outdoors, is protection, the protection of the AP itself, right? Whether we're protecting the AP from the elements, right, from the weather, maybe we're protecting the AP from potential bad actors outdoors, but maybe to our design we can make sure we add weather enclosures or physical security kits, something to our APs to make sure that our APs are not only safe and sound, but can last us for years, right, and not affected by the weather. All right, so we've gone through our gather requirements phase. We've gone through our consider the details phase, and now you're saying, Jan, can I please just start designing my Wi-Fi? Now we finally get to that point. Hey, we can put pen to paper and we can start designing the Wi-Fi after we've gathered the requirements, we've considered the details, we are ready. And I will add one thing too, is that I wasn't able to cover every single detail or every single requirement you should consider. Don't feel like you're limited. Oh, I will only look at the things that are in this presentation. Try to gather as much information as you can. Just for the respect of time, I didn't touch on every single detail. Some of them can get pretty minute. But try to gather as much information and details you can before you jump into, hey, let's start creating the design. That's for our presentation. Let's assume we've gone through all that, right? We've gathered the requirements. We've figured out the details. We have a general idea of what we want, and now we want to start on the design. And so we started with a napkin design. And a napkin design is exactly what it sounds like, right? We take a floor plan of our facility or a drawing of our facility, and we sketch out where we think the APs should go. Now, at this stage, you don't have to be super detailed yet, right? This is a starting point for our design before we get to the beefier aspects like software modeling or real-world modeling. But we just need a starting point for our design. And use as much of the intelligence from the information gathering steps that we took. Use as much of that as possible, right? But don't wreck your brain on minor details. I'm hey, am I going to put the AP here, or am I going to move it 2 feet this way? This is just a general idea. Hey, this is our starting point where we think the APs could go. Honestly, a napkin design can take you 30 minutes or less, 15 minutes, if it's a small space. This doesn't have to be a exhaustive effort. We're just starting off with something we think might work. Now, in a best practice scenario, I recommend we don't stop here, right? I recommend the napkin design as our first step, and then move on to the next step of software modeling. But for some of you, you'll stop at the napkin design, and that'll be the extent of your Wi-Fi design, right? I don't recommend it, but I think more than 50% of all Wi-Fi designs out in the world are just this. It's just somebody sketching it out and going, that looks good. I think it'll work. And Wi-Fi is a very resilient technology. So more often than not, it does work pretty, it works, but it's not going to work super well, right? This is why people complain about the Wi-Fi. And this is why complaints about Wi-Fi are sometimes an engineer's worst nightmare, because you just can't figure it out of what's wrong. Many times it starts from our designs. If we don't put effort into our design, then we're not going to get good results. So if you do stop here, it takes about far the least amount of effort, right? So if costs and time are concerned, half an hour for the design, you're done. But it's also going to be the least accurate and the least the worst performing of the designs. But if you're choosing to move on to the next step, congratulations. Your design will be that much more accurate and honestly will better meet the needs of your organization. So with the software modeling stage, what we're doing is we're taking our napkin design, right? We kind of sketched out where we want our APs to be, and we take that and we input that into the Wi-Fi modeling app of your choice, right? So for my personal favorite, it's Ekahau. That's a screenshot of an Ekahau design, but it doesn't have to be. There are other applications out there. Just make sure it's a good application, right? Your design will only be as good as your software model. So if it's a cheap model, then you don't have that much more information into your design. So that's why I personally, I use models that I think will be as accurate as possible. So this stage is more accurate than napkin design, but it takes a lot more time to do. With a software model, what we're doing is we're kind of recreating the facility within that application itself, right? Within the software model. So we're putting the floor plan in, and then we're adding the walls, right? The wall type, the ceiling heights. Maybe we're adding some of the furniture to the floor plan, and we're literally drawing it in, right? And this part does take time, but it creates a much better design. It's a more informed, more accurate design. And then what I recommend is, if you're able to, I recommend supplementing that software model with actual physical measurements. So maybe a quick on-site visit. It doesn't have to be, an exhaustive process, but just run out to the facility if you're able to, right? If it's already built or if it's close to you, bring a laser measuring device and measure the ceiling height, measure the room size, and make sure that maybe the floor plan you have is accurate. I have seen it before, to where, somebody asks, hey, can you do a design for this? And they have a floor plan, and I work on a design, and then I didn't go on site and didn't check it. And then I'm like, hey, I probably should go on site and, validate that the floor plan is accurate. I go on site and I realize, oh my God, the floor plan isn't even accurate. Right? This was a warehouse, and some of the aisles had moved. The ceiling heights weren't accurate. Even the space itself was off by like 3 or 4 feet. And so your design is going to be only as good as your floor plan. So if it's possible, if you're able to, I would recommend go on site and just validate how accurate your floor plan really is. But so, as opposed to the napkin design where we're taking 30 minutes or less, with a software model, I'm not going to lie to you, it does take more time. So I would expect to spend at least 2 hours, I think minimum, even for small locations, around 2 hours to recreate the floor plan, create the design, play with the details a little bit. But then if it's a more complex space, maybe a large warehouse or just a larger site, and if you're supplemented with a site visit, maybe it's further away, it's easy to get to 8 hours, 10 hours, 12 hours to create a design. So that is where I do say it is more, I'm not gonna lie to you, it is more exhausting, or it requires more effort than just a napkin design, but it is also significantly more accurate, right? Because now we're not just throwing APs up on a floor plan. Now we're actually getting some actionable information from our software model and saying, okay, this is what the software model says the signal propagation would look like if I put APs here, right? This is how a wall would have an effect on my signal. This is how an aisle in a warehouse would have an effect on my signal. So for the vast majority of designs that I've seen, this is where most people will stop, and they'll say, okay, my design's ready, I can convert the BOM. But for some of you, you'll say, no, I still need it to move more accurate, I still want more. And this is where we jump into the real world modeling of our Wi-Fi design. So when I say real world modeling, I'm talking about doing something that's called an AP on a stick survey. And so what we're actually doing is we're taking real access points, preferably the models that we want to install, the models that we have in our design. We put them on mobile tripods, and then we literally go around and we physically place them on these tripods to where we want to install them. And then we use a wireless site survey tool to check how the RF, the radio frequency, right, actually propagates throughout the space. So the reason most don't do this is just cost, right? It takes time to do this. You have to have the tripod, you have to have APs. But in an ideal world, I'd recommend an AP on a stick survey every time, just because it's that much more accurate, right? You take an actual real-life measurements of how the signal propagates from the AP. You're not even relying on the software model that much, right? So it's just that much more accurate, and that much better for the design itself. But it is more, it takes more time, right? It takes time, it takes effort. But for most, especially complex deployments or deployments where you rely on your Wi-Fi, so maybe a wireless first approach or design, if you can, I would recommend this stage for sure. So what do these actually look like, right? So I took a design we did last year, and I just took screenshots of the different phases just to show you or give you an idea of what each phase looks like, right? So here's a design we did last year for a small facility. This was a Brownfield deployment. So we had some limitations on where we could and couldn't put APs. But we started with just a napkin sketch, right? This is just a PDF, and we just threw some APs up in there and said, okay, hey, this is based on where we can and can't put APs, this might make sense. Put more APs in the more dense areas, the more open spaces, just put the one AP. And so that's what we started with. And then we took that and we said, okay, let's create the software model. And so I went into Ekahau and I resketched out the floor plan, added the walls, the cubicles, furniture, glass, windows. They have a lot of mirrors in this place. And then, hey, how does it actually look? And it actually looked pretty decent. We did make some small adjustments and moved some APs around. But for the most part, like, okay, this is not too bad. Okay, we have a decent idea. And then we went the full enchilada and went the whole way and said, okay, now let's validate how this looks like in real life with an AP and a stick. And we put those APs up on tripods, and that's what it looked like. I'm like, oh, that's actually pretty good. So we didn't make that many changes from the software model to the real-world model, but at least now we knew, hey, that looks pretty good. We did make a few changes, right? So in the top right corner, you see it's a little bit less signal, so we kind of moved one AP over there because the software model, for some reason, didn't quite have it as accurate in that area. But so that's kind of what it looks like. And then, once we're here, we say, okay, hey, we're done with the design. Now what? So once you're satisfied, whether whatever phase you stopped at, hopefully you got to at least a software modeling phase, but whatever phase you got to, now we actually take our design and we convert it into, or we create the bill of materials. And this is where we actually make our design actionable, right? Where it's no longer just APs on a piece of paper. We now have a bill of materials that we can price out, we can budget, we can procure. And here I would say, some vendors are easier to create BOMs with for others. If you want, you can just work with a partner of a manufacturer. So this is something we do for a lot of our customers. We create, we help them with BOMs. We help them with all phases, but this phase especially, sometimes it's easier to ask a vendor to price it out for you. But if you're doing it yourself, I would say, it depends. Some are easier than others. Like, for example, this is a Meraki BOM. I would say Cisco Meraki is probably one of the easiest to create BOMs for. They have a very easy and straightforward to understand part numbers and licenses. But for others, it can be harder. So if you're doing one of the harder ones, I would say don't forget things like licenses. Sometimes you add APs and the licenses aren't overtly clear how you add them or which licenses you need. Sometimes antennas are annoying to add. Sometimes they just aren't included by default. Things like mounting kits. So like for example, the Merakis have mounting kits that are included by default if those fit what you need. But sometimes you need other ones, right? So for example, in this one, I had a couple more mounting kits that I said, hey, yeah, we need other stuff. And then other accessories, right? So this is kind of a blown up version of that BOM just so you can see better. Right, we have our access points. So for this one, we said, hey, we need 12 omnidirectional APs. So we, earlier in this in the presentation, we were talking, hey, do we need omni or do we maybe need directional? We have 12, our typical omnidirectional APs, but then we also have 4 APs that are directional, right? Still internal antenna, but a directional AP because for this facility, they had some locations with tall ceilings. We didn't want to put an omnidirectional, so we had an AP that shoots signal down. We had it pointed down, so it's kind of like a cone of coverage. You'll see that quite often if you maybe have warehouses or tall ceilings. You don't have to shoot it down an aisle. You can shoot it just pointing straight down from the ceiling, and you're almost recreating the omnidirectional experience even in a warehouse. And then for this one, we mentioned switches earlier, right? Hey, do we need a switch? For this one, we needed a switch. We decided to go with the multi-gig model, so it's multi-gig, 90 watts of power, very future-proof, right? We don't expect bandwidth or power will be an issue for this deployment or even for future deployments if the switch wants to support that. And then it's important to look at just not just your equipment, but the non-vendor equipment. So for example, we had non-Cisco equipment. We had a pole mount kit for one of the APs that was required. So one of my favorite third-party vendors is Axeltech. We got one of their pole mount kits. We got a couple of their, or 4 of their mount kits for those directional APs, so we can point them. It's articulated and we can point them in direction. And then things like patch cords, right? There's been a couple of projects I've been a part of to where somebody orders the equipment, everything looks great, you get on site to install, and then somebody goes, hey, where are the patch cords so we can connect the APs to the switches or to the patch panel? And it's like, oh crap, nobody bought the patch cords. So don't forget things like the patch cords. And then even after all that, right? So we have our design, we have our BOM. I think I mentioned before, Wi-Fi can be very iterative, so things can change. Things can change between um, your design implementation, and even sometimes after the implementation itself. So, for example, let's say you have a great design, and then you go to implement, and your installer goes, "Oh man, we can't put APs here. We just can't get our lifts in there. Let's say the corridor is too narrow or something." And that'll happen sometimes where you had a great idea, you thought you vetted it, you thought you validated it, but you have to make a small adjustment. And that happens all the time. Don't take it personally. That's just how Wi-Fi is. And then the same can happen even after installation, right? Your design was good, you had no issues in installations, you install it, and maybe you already have clients using the Wi-Fi, and you realize, oh crap, I need to make a change, right? This can be as simple as some furniture got installed you didn't expect, or something changed in the environment. Maybe business requirements moved or changed, and people moved from one area. All right, for me, I just had this happen a couple months ago where we installed the Wi-Fi and it was good, and then nobody realized this was for a lab space, that in the lab space they were going to put a lab machine that's about 10 feet tall in one corner, right? It was supposed to be in a different area, but then the lab scientist said, no, we don't need it here. We actually need the lab machine here. And they moved the machine, and oh, it's now directly in front of an access point. And they started complaining about the Wi-Fi within the first couple of days. And so we went out there and realized, oh, we kind of got to move, the access point. This was not a change we foresaw. So even after installation, you can make a change. And this is where validation surveys are very important. I personally don't believe that any good design can be done without a validation survey. I think every design, you should have something where you validate the design after the fact, right? Even AP in a stick, with all the effort and the money required, it isn't 100% accurate because most of the time we're doing that without people there, right? Because of the difficulty of doing an AP in a stick survey, you rarely have people there. You're usually doing it on a weekend or after hours, whereas this Wi-Fi is going to live and breathe with people using it, people walking around. And so it's important to validate our designs afterwards, right? Go out there, take a site survey toolkit and walk around and see what it actually looks like, right? And validate the primary coverage, make sure we have, if your requirement is -67 signal strength, dBm, validate you have that. Maybe your requirement is -70 or -65, whatever it is. If you're doing a lot of roaming or you're doing a lot of voice or video, you also probably want to validate secondary coverage, sometimes even tertiary coverage. So sometimes we want to have 2 or even 3 APs be able to service a client. That's especially true for like voice and video. We want to make the handoff experience for the client device very easy and very streamlined. So go out there, validate, you have that. Maybe you want to validate performance. Validating channel interference is very important. I know in today's world, for the most part, we don't really do channel planning ourselves very often. Most people just rely on the manufacturer, right? Their kind of AI to figure out the channels. But sometimes even the AI want people to figure it out just because you have too many APs in too small a space, and you had a good idea, but you realize, oh crap, I have a lot of interference. And it's going to especially happen in 2.4. So maybe we designed our Wi-Fi to be good for both 5 and 2.4, but we have a lot more space in the 5 gigahertz space. What I've seen be done before, and what we've done before, is maybe turn off some of the 2.4 APs. So some of the APs will broadcast only 5, and some APs will broadcast 2.4 and 5, just because you created a more dense design to service 5 gigahertz, but now you can't service 2.4, and your validation survey says, hey buddy, half your facility has channel interference in a 2.4 space. Turn off some of the 2.4 radios and half the APs or something like that. And then kind of to that point is make sure you're validating whatever spectrum you're actually using. So if you're using 2.5 and 6, validate your signal in 2.4, 5, and 6. Don't just go out there and validate 5 only and then realize, oh, our guess is on 2.4. Well, no, sorry, you have to go back out there and revalidate it again, because if we're using it, we should validate. So that's kind of the wireless design guide at a whole. That's mostly high level. We didn't want to, for time, this still took 45 minutes. So I didn't want to go into details too much, but for sure, if you have any questions, if you want to dive into any of the additional details even more, don't hesitate to ask. This is something that we enjoy very well. I love it. Jackie loves it. We have other engineers that are really good at Wi-Fi design. So yeah, don't hesitate to ask if you have questions. Jackie, thank you. At this point, I'll give the ball back to you.
Great. Thanks, Jan. That's a lot of good content that we went over. And I kind of just want to mention that what Jan did talk about regarding the design portion. We at LA Networks, we do this. We can help with a project if it's needed. I know there's a lot that can go into the wireless design, as you have seen right now, and the entire process might be a little overwhelming at certain degrees. So please keep us in mind. We are a good resource. We do, we do provide and work with predictive surveys. We can validate, existing designs that you might have. We can help in the procuring your hardware, installation, initial configuration process. And we can also be a good resource for your post-design and implementation needs. So we do a lot of post-validation surveys and periodic health check assessments. So I think those will be very beneficial for an existing environment. We also provide Wi-Fi managed services for those of you who are looking to outsource support, management, and maintenance. We can absolutely lend a hand in every step of your wireless life cycle. So please contact us if you have any projects coming up, or if you'd like to inquire about our wireless assessment surveys, or just have any questions. We would really be happy to help. Okay, so this does conclude the webinar portion. We might have some time for some questions here. So I do see one from Connor. Does having multiple SSIDs per AP decrease performance? Yes. I would say the standard or best practice, try to keep it within 3 or maybe 4. It's just that having a lot, it's wireless users aren't really actually communicating, but the SSIDs itself, just beaconing and sending that traffic to notify users that there is a network here. That initial management communication, it will use up the AP's performance. So I would try to keep it minimal. The basics. If you have like an employees society, a guest, and maybe an IoT, try to keep it at that. There are ways that you can maybe bundle some by using IP. I think multi SSID solutions where you can actually have one SSID and be able to segment that into multiple networks depending on the pre-shared key that you have. So there are ways to kind of try to minimize the overall management traffic that goes through. Okay, and here's another question. Is it better to design with more APs than less? That's a good question. I think more APs is better than not enough. But too many APs might cause some issues. I know. So if you have more APs, then it will give you more coverage, more redundancy and secondary signal coverage for better roaming situations, and definitely help in high capacity type of high density type of environments. But too many APs might pose a challenge with designing your channels and having a lot of co-channel interference. So that could be a problem, but it also can be addressed, with just turning off the radios or putting them on monitor mode. So there are ways to go around that. But, budget is also a thing. So, would you really want to get so many APs, so many extra APs that you don't really use it? So I think it really depends. I think this does bring up a good example of, where a good predictive design might help, along with gathering some good accurate requirements. So if you have an accurate depiction of what your wireless requirements are, and you're able to translate that to, a design, whether that be like a napkin design or software model, it will definitely help give you an idea of like the optimal APs for your needs. Again, please feel free to contact us. If you have any further questions, we are absolutely here to help you out. We'd like to thank everybody today that joined us. We hope that you were able to extract some good information from the session. And yes, I hope we can see you again in our next webinar. Thank you very much.
Need help? Call our cybersecurity team and book a consultation with us today.